Welcome back to I'll Learn. This is Mr. Clark, and today we're going to be talking about adding fractions that do not have common denominators. We'll be figuring out how to make those common denominators so that we can add our fractions together. There are a lot of steps in today's video, so as always, hang out to the end to see the notes page. To be able to do this, you'll need to understand equivalent fractions and how to add fraction once the denominators are the same. If you're unsure of either of those, check out our previous videos. Links in the description. Take a look at this example. Here we have 2/6 plus 2/4. This picture shows that I can't take these 2/6 pieces and put them in with the square that's cut into fourths. We need to figure out how to divide both of these into the same number of pieces so that they can be added together. When doing this, there are a lot of steps, so it's very important to keep your work organized. This is the setup I use to make sure that I can keep track of what's going on. I draw a vertical and a horizontal line to help myself make quadrants, or 4 separate sections. In the first quadrant, the top left, I write my original problem. In the second quadrant, I find common multiples of both denominators. I use the third quadrant to make equivalent fractions, and then the fourth quadrant to solve and simplify my new equation. Thinking back to the fractions that we started with, 2/6 plus 2/4, I'll write those fractions in the first quadrant where I keep track of my original problem. Then I'll move to the second quadrant to find common multiples of both denominators. To do this, I'll write those two denominators, my sixths and my fourths, and I'll write their multiples. My multiples of 6 are 6, 12, 18, 24, and 30. Those are the first 5 multiples of 6, or 6 times 1, 6 times 2, 6 times 3, 6 times 4, and 6 times 5. You can keep going if you need to, but I usually like to start with the first 4 or 5 and see where that gets me. Now I'll write the multiples of 4. 4, 8, 12, 16, and 20. I'm going to look for any multiples that these two numbers have in common. And I see they have 12 in common. What that tells me is I can make equivalent fractions for both of these that have 12 in the denominator, and then I'll be able to add them together. Let's make our equivalent fractions now in the third quadrant. I'll take my 2/6 and my 2/4, and I'll make sure both of them have 12 as their new denominator. For my 2/6, I multiplied that 6 by 2 to get 12, so I'll also multiply my 2 by 2 to get 4. 2/6 is the same as 4/12. For my bottom fraction there, 2/4, I had to multiply my 4 3 times to get to 12. So I'll do the same with my numerator and multiply that by 3 as well. 2/4 is the same as 6/12. Now I can write my new equivalent fractions in the same order that my original fractions were in, and I can add them together. Remember, when adding fractions, we add our numerators first. 4 plus 6 is 10, and we keep our denominator the same, so it stays as a 12. This is a great answer, but if you want to take it one step further, you can simplify and end up with a result of 5 sixths. It can be very useful to visualize this, so here we have our original shapes. We can see the 2 sixths in blue and the 2 fourths in yellow. We'll cut the sixths in two, and I get 12 of them with 4 shaded. 4 twelfths. That was our equivalent fraction. If we remember, the 4 had to get multiplied by 3, so each square there becomes 3 new rectangles. We can see that 6 of the 12 are shaded, so 6 twelfths. Now that each of them is cut into the same size piece, we can move the 4 twelfths in with the 6 twelfths to see that our total really is 10 twelfths before being simplified. Let's take a moment and do one more example. This time, I want you to help me out. Remember, we'll start in the first quadrant with our original problem. This time we'll be adding 2/3 plus 1/5. Again, I'm going to take both of my denominators and write them in the second quadrant to find their common multiples. First I'll write my 3 and then my 5. Looking at the 3 and the 5, can you think of a multiple they may have in common? I have one that comes to mind right away, but let's see if it's the least common multiple of these two numbers. I'll start with my 3. 3, 6, 9, 12, 15. Again, I'm doing 5. It seems to be a good place to start. And I'm separating all my values with a comma just so I can tell they're separate numbers. Now I'm going to find the multiples of my 5. I really only need to do this until I find a match. I don't have to keep going. So let's try this out. 5, 10, checking for a match. Not yet. 15. Oh, there. The least common multiple of 3 and 5 is 15. Let's go down to the third quadrant now, and we'll make equivalent fractions. I'll start with my 2/3, and then my 1/5. Looking back up to that second quadrant, what was the common denominator we're going for? That's right, 15 is what I want both of my denominators to be. What did I multiply my 3 by to get to 15? 5. So I also have to multiply my 2 by 5. 2/3 is the same as 10/15. On my second fraction, I had to multiply my 5 times 3 to get 15. So that means I have to multiply my 1 by 3, and I'll get 3. 1/5 is the same as 3/15. I'll rewrite those now in the same order they were up above. 10/15 plus 3/15 is equal to, add my numerators, 13, keep my denominator 15ths. 10/15 plus 3/15 is 13/15. It's always a good idea to circle your answer just to help yourself stay organized. I know that there was a lot in today's video, so here are our note pages. You can copy them or download the free PDF versions free on my Teacher Pay Teachers store, link in the description. On the right, we have our steps, what to do in each quadrant, along with the definition of least common multiple. Remember, that is what we're going for because it will save us more time when simplifying. On the left, I wrote out one of our example problems, 2/3 plus 1/5 equals 10/15. I left a spot for you to do one of your own as well. Make sure that you're filling out the summary section to help you put all your learning together. Thank you for joining me today. If you have a different way that you like to organize your work with fractions, I'd love to hear about it down in the comments. As always, we want to keep those comments positive and helpful to others who are here to learn. If you found this video helpful, please like and subscribe to help others find it as well. Finally, I'd like to give a shout out to the 5th grade students at Kealakehe Elementary School. Thank you for your support and suggestions.